Let's talk radical functions and what their graphs look like, which is part of section 8.7. Again, we're going to start with the parent function. The parent function, f of x, is equal to the square root of x. Now, for the purposes of this section, and to keep things simple, we are only going to talk about square roots. We're not going to talk about cube roots, fourth roots, fifth roots, or any of those. We are only going to focus in this unit on square roots. Please don't forget that. Okay, now, since we're dealing with square roots, and I'm going to erase that, let's say I was going to graph this and I was going to make a t-table. My first question to you is, can I pick negative numbers to go in there for x? Well, I really hope at this stage that you all realize that you cannot take the square root of a negative number. It is impossible. Therefore, what will my domain be? Well, can I take the square root of 0? The answer is yes. How about square root of 1? Yes. What's the next perfect square that works out? That would be 4. The next perfect square would be 9. So therefore, the domain of all radical functions is all x values that are greater than or equal to 0. You cannot pick negative numbers. No negative numbers, people. All right, well, what do we get? If we put 0 in for x, the square root of 0 is 0. If we put 1 in for x, the square root of 1 is 1. If we put 4 in there, the square root of 4 is 2. Square root of 9 is 3, etc. So my question to you now is, do you see any negative numbers in the y column? Well, again, the answer to that question is no. Therefore, the range is all numbers that are also greater than 0. Now, let's plot our dots. 0, 0 is about right there. 1, 1's right there. 4, 2 is right there. 9, 3 is right there. So it's going to make a curve something like that. And that, people, is what a radical graph looks like. That's the function. It's a smooth curve that slowly rises. All right, well, let's talk about the transform radical functions. Yes, and here we go again with transformations. Again, everything is color-coded for you. We have our a value, we have our h value, and we have our k value. And they work the same, people. A is a stretch or compress with, again, the same criteria. Stretch is the absolute value of a is greater than 1, and compress is when the absolute value of a is between 0 and 1. H, again, moves the graph left or right. However, also, we're going to talk about the domain. Now, on the prior slide, if you look at the prior slide says the domain is x is greater than or equal to 0. Now, when you have a transform function, the domain will be this h value. So the domain will be x is greater than or equal to whatever h is. Beautiful. K moves the graph up or down, and therefore our range works the same way. Our range will be y is greater than or equal to whatever k is. Good. Let's try one example. Let's graph this radical function. Negative 3 times the square root of x minus 2 plus 5. What's the parent function? Well, we just said it. You get rid of the a, you get rid of the h, and you get rid of the k, and the parent function is f of x equals the square root of x. That's the parent function. Get rid of some of these minus or these underlines. What or how is the graph transformed above? Well, first of all, that negative, first thing it does is it flips the graph upside down. What does the 3 do? It stretches by factor of 3. What does the 2 do? The 2, that moves the graph right, moves graph right 2. And finally, what does the plus 5 do? That moves the graph up 5. And that's what this does. That's how this graph is going to be transformed. What's the domain? Well, we just talked about the prior slide. The domain is x is greater than or equal to whatever h is. Okay, so let's go back. Now, in this particular case, h is 2. So therefore, our domain, we're going to have to pick x values that are greater than or equal to 2. Now, what's the range? Well, the problem is this graph is flipped upside down. It says positive 5, but I believe that the range, and we could correct ourselves here at the end, I believe that the range is going to be all y values that are, we'll have to test this out. We'll have to see. I believe it may be less than or equal to 5, but we're going to give it a try here, people, in just a second. So I'm going to put a question mark there. Let's see what happens. All right. Let's make a t-table. X, y. Well, first of all, what numbers are you going to put in for x? Well, remember, inside the parentheses, that can't be less than 0. So the lowest number I can pick for x is 2. Now, if I put 2 in there, 2 minus 2 is 0. The square root is 0, 0 times negative 3 is 0, and I get an answer of plus 5. Okay, it looks like I'm going to be right here, possibly, for our range. What's the next number that works out perfectly? Well, I believe x is 3. Because if I put 3 in there, 3 minus 2 is 1. The square root of 1 works out evenly, which is 1 times negative 3, which is negative 3 plus 5. We'd get a value of 2. What's the next one? Ooh, now we got to do some thinking. The next one would be if this came out to be 4, which means x is 6. 6 minus 2 is 4. The square root of 4 is 2 times negative 3, which is negative 6, plus 5 is negative 1. Beautiful. And last, we want that part to be a value of 9, which means x must be 11. If x is 11, 11 minus 2 is 9. Square root of 9 is 3. 3 times negative 3 is negative 9. Plus 5 would make negative 4. Yes, so I believe our range is correct. It is less than or equal to 5. Now let's plot that guy. Let's see. 2, 5 would be right here. That's 2, 5. Then 3, 2, which would be right there. 6, negative 1, which is going to be right there. And 11, negative 4 is going to be way off the chart right here. So our graph looks like it got flipped upside down, and it goes like this, starting right there as best I can do. And there you go. That's the starting point. It can't go past that point. So therefore, our graph did get flipped upside down, and it got stretched by a factor of 3, which means it got elongated in that direction, and it's right 2 and up 5. And there you go, people. That is how you graph transformations for radical functions.